In today's lesson we try to learn chemical energetics, which will not only cover IGCSE but also some of the part of AS level energetics. Now we discuss types of chemical reaction on the basis of energy change. First type of chemical reaction is endothermic. Energy absorbed. Energy of the surrounding decreases. Reading on the thermometer falls. Enthalpy is always positive. Energy of the reactants is always greater than the energy of the products. Bond breaking is always endothermic. Dissolving of metal nitrates is always endothermic. Photosynthesis is always endothermic. Thermal decomposition is always endothermic. Second type of energy change during any chemical reaction is exothermic. Energy released or given out. Energy of the surroundings increases. Reading on thermometer rises. Enthalpy change is always negative on energy profile diagram. Level of energy of products is higher than the energy level of products. Bond making or bond forming is always exothermic. Reaction of reactive metals with water or with acids is always exothermic. 2. Respiration, which is the inverse of photosynthesis, is always exothermic, while combustion of carbon or hydrogen or of any compound containing carbon and hydrogen is always exothermic. Energy profile diagram for two energy changes is shown. You can easily compare two energy changes. An exothermic change is shown on the left side, whereas on the right side, energy profile diagram of an endothermic change is shown. You can easily notice that energy level of products is higher than energy level of reactants during an exothermic change, and shows that reactants are less stable and requires less energy to break the bonds present in reactants, while the energy level of product during exothermic change is lower than reactants, showing that products are more stable than reactants, and requires more amount of energy to be broken down. On the other hand, energy profile diagram for the endothermic reaction, which is on the right side, indicates that reactants are more stable, requires more energy to be broken down, and the products are less stable than reactants, and requires less energy to be broken down. Note that enthalpy change, which is represented by delta H, is always pointed from level of reactants to level of products in energy profile diagram, whereas activation energy, which is represented by capital E and small a, is always endothermic, and is always pointed from level of reactants to the peak of the curve. To calculate the enthalpy change, we use the following formula. This formula only works when bond energy data is presented by Muhammad Bilal, M.Sc. Chemistry. Please provide your feedback. If you consider it helped, your feedback will help and encourage to make more videos on the other topics of the IGCSE chemistry and A-level chemistry syllabus. If you missed any of the topic you studied at school or college, and you are struggling, do not hesitate and contact me on my WhatsApp. Thank you for watching the Wellstand Chemistry tutorials. Please like and subscribe the channel to get future videos on time.